Hi everyone, welcome to the second day session. Hi madam, good evening to
Hello.
one.
Hello, sir.
Yes, ma'am.
Hello, I am audible, sir.
Yeah, I'm audible, ma'am. Now we can start the session, please.
Okay. Okay, my screen is visible.
Yes, your PPT is visible.
Yes. Okay. So let's recall the yesterday session. So in yesterday's session, we talk about means what are the different steps of the knowledge delivery. In that, we already see that the first step is data cleaning. Okay, so in data cleaning, we done real life hands-on experience to clean the data which has the missing values in a quantitative data as well as for the categorical data. We are dropping, we already done for deleting the missing values as well as we have done with the replacing the missing values by some statistical value or by some random sampling. Okay. So the next portion I have to cover, then what are the different functions of the data mining? Okay, so what are the different things that we can do with the help of the data mining? So the first thing is we do a generalization. So what do we mean by generalization? That we uh, construct the data, we integrate the data in the form of the data warehouse. Okay. So what is a data warehouse? Basically, a data warehouse is a data structure that hold the different information, not the raw data. So what is if I say what is the difference between database and data warehouse? So database stores the raw data while data warehouse stores the extracted data or the meaningful information that we extract from the data. So that we store in a data warehouse. So that data warehouse is constructed after doing the data cleaning, data transformation, integration, and for that we have to use the different types of the data warehousing techniques like OLAP. In data base, we are using OLTP techniques for storing for the data set, while in the data warehouse, we have to use the OLAP, that is the online analytical processing technique. Okay, and the database is a multi-dimensional data structure, and for that, we have to use a data cube technology. Okay, so if you have to convert the data, means double dimensional data into a multi-dimensional data, then we have to use the OLAP or the data cube technology that we can do with the help of the data mining, but that is a totally database part, and mostly the database administrator, database analyzer can do these types of generalization functions of the data mining. Now, the second very important thing that we can do with the data mining is a association and correlation analysis. So basically, as if you heard about one term, that is a market basket analysis. So what is market basket analysis? I take a one example that we go in any supermarket and want to purchase something. What is the general trend here? Seeing that we take a one basket and hold all the necessary things that we want in a basket. So if we analyze the each and every customer basket, that what are the things they are trying to buy with the another product, this is called the market basket analysis. And that market basket analysis is we can do with the help of the finding the frequent patterns of customers. And for that, there is a one algorithm that is called the a priori algorithm that is used to do the association and the correlation analysis. And this is very useful for the any supermarket to know the trend of the customer and what are the different things that a customer can buy with the other products. For example, dairy product like if a customer buy a milk, then what is the probability that customer can buy a curd or a cheese also. So this type of relationship we can also find with the help of the data mining. And for that, we can use a algorithm, a market basket analysis, and the means management term we are using for same is a market basket analysis. Okay. Then what is the most important and now in a very trend that that we can do with the data mining is a classification. Okay, so what is a classification? Classification is a one type of dividing the data into some labels that are previously known to us. So basically classification is also known as means supervised learning algorithm that we heard in a machine learning also. So what do you mean by supervised? That the class labels that we want to predict are already known to us. For example, if there is a data set that a customer can buy a computer or not. So what are the different independent parameters that are associated with it? For example, the age of the customer, the means spending habit of a customer, then what is the education level of a customer. These are some independent parameters that are dependent that a person is buying a computer or not. So the parameter, the buying computer or not, there are two labels, yes or no. So these labels are called as class labels. And we have to identify that these class labels are constructed by the model using the classification algorithm are true or not, and if true, then how much true. So we have to evaluate the classification models on the basis of some evaluation parameters. Okay. So what are the different algorithm of the classification that are mostly used by the researchers? Are decision tree algorithm, naive-based classification algorithm, support vector machine algorithm, that is SVM, neural network, rule-based classification, pattern-based classification, logistic regression, and many more. These are the different classification algorithms that we can use to divide the data into a predefined class labels. So what are the different applications of classification? Like if we have to find out the credit card fraud detection, that this type of transaction is a fraud transaction or real transaction, then we can use a classification methods. Then there are various types of stars we can see in a cloud. Then how to identify that what shape gives which type of stars. So for classifying the stars, we can also use a classification algorithm like some diseases prediction that on the basis of the symptoms, what are the different type of diseases a patient can have. In that also we can use a classification algorithm. Web page classification, for example, if we are searching on a Google and Google gives extract some pages on the basis of our query given to a search engine, Google is also using a classification algorithm for the same to identify the best pages associated with our query. So these are the different things that we can do with the help of the data mining. So in today's lecture, I am going to cover some classification algorithms like decision tree, name-based classification. There is one algorithm, random forest algorithm, KNN algorithm. So these are the different algorithm, and I want to give you a hands-on experience that how to apply these classification algorithm on the data set, real-time data set, and how to interpret the results. Okay, so this is our today's objective of this session. So I want to start to cover this classification using R. So I just opened this R Studio. In today's session, we also required to install some libraries required for the classification algorithms. So we required means internet connections to load the library from directly from the internet also. Okay, so everyone is ready with R Studios. Then I can start with how to read the data and how to classify the data and which type of data we require for the classification. Okay, so can I start? So you can interact with me using a chat. Okay, so I first I want to give you a brief idea that what type of data set we require to to perform a classification. Okay, so we know that if we are talking about data, let's I take a one data set that I already shared to you. That is, for example, it's a wine quality. Okay, so I just opened this data set to explain you that classification algorithms are applied in this data set or not. And if yes, then why is, and if not, then why? Okay, so we have to first understand the data set and then we can apply the classification algorithm. Okay, so you can see this is a one data set of the classifying the quality of the wine on the basis of the some parameters. Okay, so if we see some parameters here that there are some columns we can see in this data set. Now we have to identify first that what columns are independent and what columns are dependent. For example, if we are talking about our BMI index, okay? So BMI index is basically based on the height and weight of a person. So we can say that the BMI, okay, you talk about the a priori algorithm. So basically, a priori algorithm is used to find out the frequent patterns in a data set. Okay. For example, if there is a record file of a superstore that customer ID, for example, one purchase different things in their basket. Okay, like it's purchase of some clothing accessories, some groceries, some milk product. Okay, so if a customer one purchase these things, uh, then what is the probability that if the second person can purchase the same product, then the nearby product has also the probability of purchasing the same item. Okay, so it gives you a cart analysis. Okay, that is not the part of actually this workshop. That is not mentioned in this workshop. But if possible, then I give you the example and run this algorithm. so that we can explain. Basically, it's used for the correlation of the product. That if a person is purchasing a product A, what is the probability that person is purchasing product B also? Okay, so that the supermarket managers can do analyze that which product is placed in means near, and which products are placed far. So you can see that the arrangement of the product in a supermarket is always changed. So why it is changed and how it is changed, it depends on the cart analysis. So mostly if if a manager is using a frequent pattern analysis or the approach algorithm analysis, then it is effectively done for the supermarket. Okay. So for the applying the classification algorithm, so I give you a one data set. Okay. So we have to first identify what are the independent parameters and what are the dependent parameters. For classification, it is required that the data set has both the parameters, means independent as well as dependent. Okay, because if there is a no dependent parameter, it means that the classes are not predefined. And if the classes are not predefined, then we cannot apply the classification algorithm. It is important and necessary that classes are predefined, means what you want to predict, that is predefined. Okay. Then you can only use a classification algorithm. For example, this is a wine quality data set. It means if we don't know that what are the different values of the quality, then we cannot predict the quality of the wine. So in this, if you see that this is a acidity level, volatile acidity level, citric acid level, sugar level, sulfate level, density level, pH values, sulfate values. So these values are the independent parameter to predict the quality of the wine. So in this data set, we can see that these A, B, C, D to K are our independent parameter, and on the basis of that, we can detect or predict the quality of data sets. So this quality is considered as a dependent parameter. It might be possible that in data set, this quality parameters are categorical or it might be numerical. But to apply the classification algorithm, it is necessary that all the independent parameter that we have in our data set having numerical values. It is compulsory. If not, then we have to convert our data into a numerical. So we can use the Likert scale to convert the categorical value into a numerical value. But if you don't have the numerical value in the independent data, then you cannot apply the classification algorithm. Understand? And in dependent column, you can find both type of values, either independent value, either categorical values, or either categorical values. Understand that? And it might be possible there are one independent column and one dependent column, or it might be possible there are more than one independent column, but it is necessary that there is at least one dependent column. If there is no dependent column, we cannot apply the classification algorithm. In that case, we have to use the unsupervised learning algorithms that comes under clustering. Okay, understand, everyone? Okay, so we have to first understand what is our data set. is data set is really used for the classification or not? If that data set is suitable to apply the classification algorithm, we can use. If not, then again, we have to either do the data cleaning, or we have to apply the another techniques of the data mining like clustering, association analysis, etc. Okay. Now, I want to give you first a very basic classification algorithm, that is a decision tree on a one inbuilt data set, that is a iris data set. Okay. So what is iris? First understand. So if I type here iris, okay, and run. Okay, what you can see. Please see the results. This is inbuilt data set. We don't have to export it from, import it from anywhere. That is available with us. Okay. So what is this data set? Let me understand. So if you can see that there are 5 columns in this data set. The first is the sepal dot length, sepal dot width, petal dot length, petal dot width, and species. Okay. Let's first understand that in this data set, which columns are independent and which are dependent. Okay. So if I want to classify that what category of flower we have on the basis of their sepal length, their sepal width, their petal length, and petal width. So we can say that these 4 columns are treated as independent columns and species are treated as dependent columns. Understand? Okay. So in this data set, we get 4 independent columns and 1 dependent column. Now let's talk about the data types of these columns. If we see that these 4 columns has which type of values, that is the numerical values. But this species column has the categorical values. Okay. Now, if I want to see that what type of, what are the different type of species we have. Okay. So you can see that there is a sentosa. This first value is a sentosa. Second is a versicolor. And third is a virgin. Okay, you can see. Okay, so we identified that there are 3 levels, class levels, that are existing with this iris data set, that are sentosa, versicolor, and virginica. Okay. Now let's talk about the mean sample of this data set. How many samples available? Okay, that is possible with Python. Okay, you can do. Okay, so minimum confidence, minimum support, and the lift, minimum length, these are different parameters that we have to pass in the a priori algorithm, and we have to find out the different rules to classify, to finding the association rules. Okay, that is possible with Python also. Okay. Now, in this data set, if we find out the dimension, okay, let's we talk about the dimension, or we have to first find out the properties of this data. So if I run this, you can see uh, this is the data frame. First, iris is a one data frame. This data frame has 150 observation of 5 variables. Means there are 5 columns and 150 rows. Okay. Then what are the columns names? That's sepal name, sepal grade, petal grade, petal grade. These 4 are the numerical. Okay, and these are the different values. And the species have the factor values with 3 levels: Sentosa, versicolor, and virginica that we see. It gives some numerical value to a particular label: Sentosa 1, versicolor 2, and similarly virginica 3. Okay, so that data set properties we already have. Okay, so now what we have to do first to find out to apply the classification algorithm. The first step is we have to check that there is a need of data cleaning or not. So you can see that this data is clean. There is a no need of data cleaning, but let's we again check that we required a data cleaning or not. So I just have to write some else dot n that we already done yesterday and iris. Okay. Now if I run, you can see 0. It means there are 0 missing values. Means we can directly apply the classification algorithm. There is a no need of data clean. Understand? Okay. Now, the first thing we have to do to apply a classification algorithm is to divide our data set. We have to divide whole independent columns in a one variable and dependent in another variable. Okay. So we know that the first 4 columns are independent and the 5th column we have is dependent. So we have to divide data into an independent and dependent part. So for that, we can do that. We have to divide data into a training and testing part. Okay. So what we have to do that first to apply any classification algorithm I write here, we have to divide data into 2 parts. Okay. The first part is called training data and the second is called as testing data. Okay. So what is the role of dividing data into a 2 part? The training data is used to build a classification model and the testing data is used to test the accuracy or the precision of that model. Okay. If you don't want to check the data, the model, there is no need to divide. You can use 100% data. Okay. But mostly when we are building any classification model, we have to check that how much this classification model gives you an accurate result. And for that, we require a one data set that is always part of the raw data. So we have to divide data into training and testing part. Okay. So what ratio we can mostly prefer to divide the data set? So mostly prefer 70-30 ratio. Okay. So means 70% data is treated as training data and 30% data is treated as the testing data. Mostly but this is not the hard and fast rule. You can make training and testing data 80-20. You can make 60-40. That is your choice. But mostly the researchers are doing that the proportion of the training data is always greater than the testing data for better results. Okay, that mostly researchers are following. And in books, if you are prefer that, it gives you a ratio of 70-30. Means 70% data we have to take as training and 30% data we have to take as testing. Okay. Now, how we divide this data into a 70-30 part? Okay. So we can do that. First 70% data we can take as a training, and last 30% data we can take as a first 70% take as a training and last 30% take as a testing. But that is a bias case. Okay. So we have to divide data into a 70-30 using a random sample. Means any 70% data of raw data is taken as a training and rest is taken as a testing. So we have to apply the sampling technique, that is a random sampling, to divide the data into training and testing part. Now, how to do this? So to divide the data into training and testing part, first we have to use the random sampling. Okay. Now, how to use the random sampling? For example, I want to take a training data of 70%. Okay. So we already done yesterday that there is a one method, that sample, which is used for the random sample. Okay. Now we know that there are how many rows in the data set? 150. But we can also pass here 150. But if we don't know that how many number of row in a data, or we want to do a dynamic programming, then we can use a n row function. N row means number of rows. So it take a total 1 to 150 data. Okay. And then find out number of rows of iris 150 and into 0.7 means 70%. Means it gives you a 70% data from using the random sampling and store in a one variable, that is a train index. Okay. Now, if I run this code and now print the dimension of train index, okay, you can see how many values you can get that are only 70% values. Okay. So if I give you a n row, that is not a data frame, that's why it gives null. But you can see that if I print only the train index, it not gives me a 150 value. It gives me a 97, 98, 99, 100, 1, 2, 3, 4, 5. Near about approximately 1055. It means we get only 70% values. Okay. So, and why we are using a sample here? Because I want to use the random sample. Okay. Now, the rest data we have to consider as a training data. Okay. So, we can write that Okay. Now you can see that what data comes in a training set. Okay. You can see the number of, this is number of rows. Okay. So we have 1 to 150 number of rows. It takes any 70% data of our original data and gives you a random number of rows and store in a train set. So this 53 number of rows, 50, 145, these are the random sampled data that we get from the random sampling, and this is only 70% data. Now, if I want to print the dimension, you can see 105 and 5 means in training data we get 105 number of rows and 5 columns. Okay, so this is 70%. Now the rest 30% data is considered as a testing data. Okay, so what is a testing data? That is not the part of the training data is considered as a testing data. Okay, so I can write, you can see here minus symbol. So what do you mean by minus? That is not the part of the training is considered as testing and is stored in a testing data set. Okay. Now if I print this, you can see the 45 and 5. Okay. Means 105 number of rows in training data and rest 45 in the testing data. And total we have 150 rows. Okay. So we can see that our data is divided into a 2 part, training and testing. Okay. Now, if our data is divided into a training and testing part successfully, then we can able to apply the classification algorithm. Okay. But to apply the classification algorithm, we require some libraries. Okay. So for applying the decision tree algorithm, we require a one package, or we can say library, that name is rpart. Okay. To apply the classification algorithm decision tree. This is used for decision tree. Okay. Second, to show the graphical result, because it is a tree, so we want to see the tree. We require a one library, that is rpart.plot. Okay, these are the library names. We have to remember the library names. Okay. Now, for checking the evaluation parameter, we require a one library for evaluation. We require one library, that is name is CA tools. It gives you a confusion matrix, precision recalls, all that parts. If you want to draw a ROC curve, AUC curve, then that is also possible with this package. Okay. So what we learned that these are the things, means this is the one type of data pre-processing where we divide data into a 2 part, trading and testing part. Check that the data don't have any missing values. Okay. And after that, if we want to apply the classification algorithm, then we want to use these packages. If algorithm is changed, these packages are also changed. Okay. Now, what we can do to install that packages. Okay. So we have to write just library dot install. And here we have to write the name of the package. Not library dot install, that is install dot library. Okay. If I run this, you can see this is working. These warnings are given, no problem. But you can see that this is downloaded and you can check a message, package R part successfully unpacked. Okay. And if you see here, this R part is available. This R part. Okay. Now similarly, you can install a library that is rpart.plot. Okay. If you are facing any problem, then please let me know in chat box. Okay. The third library we require is a CA tools. So I have to write CA tools. Okay. You can see the CA tool is available here. You can see rpart, you can see rpart.plot. All are available. rpart.plot. Okay. Now, after installing this package one time, please comment this so that when you are running the whole script again and again, this installation process is not required. Okay. Because it is already installed, we have to not install again. So I can comment this. Now to load this libraries in our script, we have to just click on this. rpart.plot and create it. Okay. You can see these libraries are embedded with our script. Understand? Everyone is with me. If you are facing any problem in installing, then please let me know. Because after that, if we are doing any means writing any commands in our script that are not able to run without downloading these packages. Okay. So now I have to apply the decision tree algorithm in our training data and to check that how the model is working, what is the accuracy of the model, we have to use the training data. So we have two variables. That is one is a train set and second is a test set. Train set has 70% data and test set has the 30% of our data set. Okay. Okay. Now to apply the decision tree algorithm, we have to use a method that is a R path. Okay. So I can use this is the R path. Okay. And the column which are dependent in our data set, you have to write first. Okay. Then you have to write the tilde sign and this dot. What this dot means, all the rest of the parameters. So you can know that in our training set, how many columns we have? 5 columns. In 5 columns, the first 4 columns are independent and the last column is dependent. The dependent column name is species. So what here dot means? Dot means sepal dot length, sepal dot width, petal dot length and petal dot width. All columns. You can write also the column name. Okay, but it might be possible there is a spelling mistake. So if we are writing dot, it means it included all the rest of the columns of the data set. Okay. Now we don't want to use the whole data. We want to use only the training data. So here I have to pass that on which data the decision tree is applied. So the data is a training data. So we have to use the train set. Okay. Now we know that in the species, which type of data we have? Categorological data. So we have to use the classification method on the basis of the categorological values, not numerical values. I already told you that in the dependent column, either we get the categorological values or either we get the numerical values. So in this data set, we have the categorological values. So we have to use method equal to class. Okay. So this statement is used to build the classification model on the basis of algorithm decision tree. So to apply the decision tree, we have to use the method rpart. If you are not installing this library rpart, this method doesn't work. Okay. Now to show the plot, we have to, because this is a algorithm that gives you a visual representation, we have to use the another method that is rpart.plot, where I have to pass the build model by the decision tree algorithm, and this is just the name of the plot. Okay, it gives you the name. Now, if I run this 2 lines, you can see this decision tree diagram is plotted. Everyone understand? Can I give you the code? Hello?
Yes, yes, madam.
Hello?
Yes, ma'am.
Can I share the code?
You can share the code in the chat box, please.
Okay, so please check this is working or not, because these are the things. If not done, then the rest of the thing that we are going to use is a evaluation of this model that we cannot able to perform. Okay, so what we have done till now, we take a one data set having both independent and dependent column. It is necessary for the classification that independent column has the numerical values and dependent column has either numerical, either categorical values. Okay. In independent column, it is necessary that we require at least one independent column and one dependent column. The number of independent columns can be more than one for apply the classification algorithm. Okay. So now what is the next step? To load the data set and check the data set required a data cleaning or not. So for that, we have to check that is there is any missing value in data set or not. If there is a missing value, then we have to done the previous day exercise to clean the data set. If not, we can directly go to the next step. So what is our next step? To divide the data into a two part. One is called as training data and second is called as testing data. Mostly the training testing data ratio is a 70-30, but you can also change the results means ratio. You can use 80-20 also. If you want to change, then you have to just change here on. Okay. Now we have to divide the data using the random sampling. So we use here a method of sample. Now the training and testing data we have to check that 70% or the 30% or the ratio you can take is divided or not. Now when the data is divided into a two part, you are able to apply the classification algorithm. Okay, so to apply the classification algorithm, we are using here the first algorithm, that is a decision tree algorithm. So for decision tree algorithm, you require a package that is called as rpart. To visualize the result of the decision tree algorithm, we require a package rpart.plot, and to evaluate the model and get the evaluation results, we required one package that is called as CU2. Okay. Now, to apply the decision tree algorithm, we have to use the method rpart. We have to first pass the dependent column. Then this is a means format that you have to pass the tilde symbol. That shows the relationship. And after that, you have to pass the name of the independent columns. If you pass dot, then it takes all the columns available in the data set. Okay. Now, why we are dividing data into two part, training and testing? Because training is used to build a model. And here we are building the model, so we have to pass train set. In train set, we already know that we have only 70% data set. Now, why we pass here method equal to class? Because we know that the dependent column specific have the categorical values. Okay. Now, to plot the decision tree, we require a method that is rpart.plot, and here I have to pass the tree that is built by the classification model iris tree, and this main equal to this is just to give the name of this plot. Okay, understand everyone? Now I have to check that how okay. Now I have to check that the model built by the algorithm gives how much % accurate result. Okay. So for evaluating, I give you here that how to do the evaluation. So basically for doing the evaluation of model, we use a one matrix that is called as confusion matrix. Okay. Basically, this confusion matrix is a matrix that stores various values like true positive, true negative, false positive, and false negative. Okay, so these are the different values that are stored by the confusion matrix. And on the basis of these four values, true positive, true negative, false positive, and false negative, we calculate the various evaluation parameters like accuracy, precision, recall, F1 score, that you can find out in various research papers. That when we are applying algorithms, then we have to evaluate the algorithm on the basis of some evaluation parameters, and mostly we are using these parameters: accuracy, precision, recall, F1 score. All these formulas are based on these four values. Okay, so if I can say, then what is the formula of accuracy? The accuracy formula is true positive divided by true positive plus false positive. Okay, this is the formula of the accuracy. Similarly, there is a formula of precision, there is a formula of recall. But to construct a confusion matrix, to find out the value of accuracy, precision, recall, we require this package. Okay, CA tools. So we already installed this package, so we are able to construct the confusion matrix. Okay, so first, to construct the confusion matrix, we required a package CA tool for table format, and caret we require. So here I write install dot packages it takes a time. Okay, these are the different dependencies for this package. So we have to first, to find out the confusion matrix, we have to first predict, do the predictions, and to do the predictions, we want to use the testing data set. So to build a model, we can say we have to use the training data, and to check that how the model is performed, we have to do some predictions on the basis of the model built by the algorithm, and for that we can use the testing data. So for using this, we have to use this method predict. Here I have to pass the model built by algorithm, that is iris underscore tree, and on the basis of what data set we have to predict, that is the testing data. Means the prediction results are only 30% of the data set. Okay. Now if I run this, so it gives you some results. Okay. means in row number 6, for row number 6 is predict that the category of flower is Sentosa. In row number 112, it predicts that classification of flower is virgin. That is predicted by model. So we have two data. Okay, please try to understand. We have two data. One is available with us in our original data set, and second, that is predicted by the model. So we have to check the data set we already have and the data set predicted by the algorithm are same or not. If same, how much percent same? If not same, then what is the percentage of error? For that, we required to construct a confusion matrix. Okay, so confusion matrix gives you that what are the actual results and what are the results predicted by the model. Okay, so for that we have to use the confusion matrix where you have to pass the two things, that is the results predicted by the model and the original results. So what are the results predicted by the origin? That is stored in a prediction, and these are the result, original result, that is stored in a testing data $species. So if I run this, and the method we are using is a confusion matrix, and that confusion matrix is available with this caret package. So I have to check here caret also. Okay. Now if I run this, you can see this is a confusion matrix. Okay, you can see this is a reference, means this is actual and this is predicted. There are three categories: Sentosa, versicolor, virginica. Here also Sentosa, versicolor, virginica. It means that the result predicted by Sentosa and the result predicted by the result that are already available with us, the frequency of that data is a 60. Okay, so this is a true positive result. You can see that it also calculates the accuracy. So you can see that accuracy of this model is 95.56%. Okay, this is a class interval. Okay, this is the p-value. You can see that in various research papers, mostly models are evaluated with the help of the p-value. So if p-value for 95% confidence, if p-value is less than 0.05, it means that the hypothesis that derived by the researchers are accepted, otherwise not accepted. So in this case, you can see that if this is e raised to minus 16, it means that it is less than 0.05. It means we can say that the model built by algorithm is a good model. Okay. And there are various types of also evaluation parameter like sensitivity, specificity, detection rate, balanced accuracy, that is calculated for all the different classes. So for class Sentosa, for class versicolor, for class virgin. Okay, so these are the different analysis that you can do with the help of the confusion matrix. Okay. Now, if you want to change the ratio, what are the different things you can observe? Okay, So for example, if I here change the ratio, okay, so I can change the ratio to 60/40. Okay, so I have to just put here 60% and the rest is 40% is allocated in the test set. What are the changes we can see in result? Okay, so if I run this code again, now if I see the result, you can see the accuracy is increased. So mostly researchers, what they are doing, they can not do a sampling one time. They try to resample the data again and again to achieve the best accuracy. Okay, so you can check for 65, 35. Okay, you can check for 60/40, you can check for 70/30, and on what ratio, which ratio you can get the best accuracy of the model that you can use for the further analysis. Okay, okay, understand the decision tree model, and that we are only performed with the help of the inbuilt data set. We can also do this with the CSV file. Okay, this is done, so I can do this with a CSV file also. Okay, now I also share you the file. Okay, so now let's perform a decision tree algorithm with the help of the CSV file. Okay, so I just open the new script. So there are some changes because this iris data is inbuilt data set. So the data structure of this data is different. And when we are using a CSV file, the structure of the CSV file is different. So we means the steps are same, but we have to do some changes. Okay. So what we have to do first, we have to read the data set. So I can write that we already then read.csv, and here I have to pass the path of the file. So I take this wine quality data set for performing the decision tree. So I just right click, properties, So now I want to print the data, so I can write print data. Let's check that data is available with us or not. So we can see that data, all the wine quality data set is available with us. Okay. So what is the next step? I have to check there is a missing value or not in that data set. So I just write print sum is dot na and maybe. If I run, you can see there is a no missing one. Okay, so we don't have to use the data cleaning part. Now, what is the next part? We have to divide data into training and testing part. Okay, so for dividing data into training and testing part, we have to use a random sampling, or for the random sampling, we have to just use this random sample. Okay, so we can use this here also. Now, in place of the iris, we have to use the data. Okay. If you want to do a 70-30 ratio, then again you have to change this. Okay. Now, if I run this, you can see that 70% data you get. Okay. You have to just change the name of the data. What are the different changes you have to do? I have to just explain. In a place of the iris, you have to just put this data, because our data is available with the data frame, that name is data. Okay. And our in this data set wine quality, you know that the name of the dependent column is a quality. Okay. Quality. So you have to use here quality in place of the specific. This tree is very big, so there is a problem in plotting. So it gives you a warning message that that is not plot very successfully. You can see the size. Okay, that is not visible. That we can do with some visualization techniques that to change in that, or we can also change the number of samples to fit the data into a particular uh, graph. Okay, now we can do prediction, and in this place you have to write quality. Now if I change this 60/40, let's check that what are the changes we get in a graph. You can see there are some changes in the graph. Okay. What you are telling that change the name of the data set? In prediction, we have to use the testing data. Okay. One second. Hello. Everyone done this? Okay. Now, the second algorithm we can do, that is a naive-based classification. And this naive-based classification is a basic algorithm that is based on the statistical theorem, that is a Bayes theorem. Okay. So, what is Bayes theorem? Bayes theorem is a basically conditional probability theorem. Uh, in this conditional probability, basically, uh, uh, if there are two events that are events A and B, and if we want to predict that what are the chances that the event A occurs given that B also occurs. So if A and B are dependent to each other, then what is the probability of having the event? That we can calculate with the help of the Bayes theorem. So, for example, if there is a rainy season, what are the chances of buying umbrella? So we know that these both events are dependent to each other. So on the basis of the probability values, if we want to classify the data set, then we can use a naive-based classification. Okay. So there are lots of questions that which algorithm is better to use. So there is an answer that no algorithm is good or no algorithm is bad. It depends on the data set, that on which data set, which algorithm gives you a better result. Okay. So, and it also depends on your requirement. Okay. So what is your requirement? Which type of data set you have? Depending on that, you can choose which algorithm you can use. Okay. So you can use either decision tree, you can either use name-based classification, that is your choice. Okay. So now we we are doing a name-based classification on the basis of the uh, data set, that is the iris data set only. So in iris data set, we know that this is a data set that is having the independent and dependent column, and this is the classification, means supervised learning. So we required at least two things, means independent and dependent column. Okay. And for running this algorithm, we required three packages, that is E1071, then CA tools, and then Carrot. Okay, these three algorithms we have to install for running this algorithm. So now let's first install this. Okay, in my system this is already available, and the version is only updated. Okay, now CA tools that I already installed and Carrot is already available. Now I'm going in the packages section and I select CA tools, then Carrot, that is required, and E1071. Okay, because you can see that this E107 is used for probability theory group, and this name-based algorithm is a part of the probability theory group, and for that we require this E107. Okay, after that I comment these all because I don't require to install these again. Okay. Now, in the previous decision tree algorithm, we use basically a random sampling to divide the data into a training testing part. There is also a second method that is called as sample.split. Okay, this sample.split is also one method that divide your data into a training and testing part depending on the split ratio provided by use. And this sample.split method is available with CA tools. Okay, so if your system you not install this CA tool, this sample.split method doesn't work. Okay, so here you can see that I divide first a data iris into a split ratio of 70% and 30%. Now this split gives true result for 70% data and false result for 30% data. Now I want to make a subset that 70% data comes in a training part and rest 30% data comes in a testing part. So where the value is true, the data comes in a training part, and where value is false, the data comes in a testing part. Okay, so if I basically run this, I have to first load this data. Now divide the data and I want to print the training data. Okay, you can see these are not total data, these are only 70% data. Some data is set, you are seeing that these are the missing. Okay, so that comes under the testing part. Okay, so if I print here test data, so you can find out this data. Okay, Now, I told you tomorrow that we can apply the scaling or the normalization of the data set. Okay. So you can see that in probability, if data set is not normal, that algorithms not gives you a good result. So it is your choice that if you want to do scaling, you can do scaling. Okay. So here I show you that how to do the scaling. So we have two data set. One is a training data, one is a testing data. For both the data set, we have to do scaling. But for scaling, you know that we require only numerical data set. And our numerical data set is available from 1 to 4th column on. The 5th column is a dependent column and that is having the categorical value. So we cannot normalize this categorical value. So you can see here I use a one method, that is a scale. This scale method is used for converting the data into a Z scores. Okay. So it takes your training data, and this comma means all rows, and here there is a 1, 2, 4 means column number 1, 2, 3 and 4. Okay. The last column is not used in the scale. Similarly, for the testing data, if you want to do scaling, using the Z transformation, that you have to scale, then test data, all rows and columns 1 to 4. Okay. Now, let's check what is the need of this seed. Okay. So, what is random sampling? That every data item from in a sample get chance to be a part of a sample. Okay. So, when I am running this program one time, the set of random sample is different. Another time when I am running this algorithm, the samples are different. It means if I run this script 2 times, 3 times, 4 times, it might be possible see that results are different because the data set is different. And I am using the random sampling, it means the data set is changed. Okay. So if you want that random sampling is performed in data, but the results are always fixed. In that case, you have to use the seed. Okay. So if your seed is same every time, then the results are also same. Okay. So if your and my seed is same, then your and my results are same. Okay. And in seed, you can pass any integer value. Okay. So this is also the optional part. If you want to set seed, then you can set. Otherwise, there is no need of setting seed. Okay. Now, to build a classification model using naive Bayes, there is a method naive Bayes. Similarly, as we passed in a decision tree algorithm, we have to first pass the dependent column name, then tilde sign, and then dot. Dot means all independent column. And then on which data we have to build the model, that is a training data. So we have to pass data is equal to training data. Okay. Now we have to perform the prediction. So for prediction, we have to use the predict model. We have to pass our model built by the naive Bayes algorithm. And for prediction, we have to use the testing data. Now to build a confusion matrix, we can use this table method. In the previous algorithm, we can use this confusion matrix. You can also use this confusion matrix here. But this confusion matrix, we required a math library cat. Okay, and you have to pass the data predicted by the model and the actual results. Okay. Now, if I run this whole code, you can see the results that for iris data and 70-30 ratio, the model accuracy is 93.33. In decision tree, we get the results 95%. So for the same data set, if we are using a different algorithms, different classification algorithm, you can see the results are different. Okay. I send you this script so you can check, and after that we can use this name-based algorithm for the data set we have, that is a mobile price data set. Okay. Again, if I you means comment this thing and run this whole algorithm again, you can see that accuracy is changed. Why? Because random set of samples are changed. Okay. If I again run this algorithm, you can see again this result is changed. Why? Because the random set are changed, random samples are changed. So every time if I run this script, I get the different result because of this random sampling. So if you want to fix the results of this script, then you have to set this C. So you can set this also 100, anything. For 100, you see that the results are 95%. If you are also setting this 100, you get the same result. Everyone done this? Okay. So can we apply the name-based algorithm on the mobile price data set? It is very easy. But in real time, we mostly use the CSV files. So means we have experience to apply the algorithm in the CSV files. Okay. So let I open a one script and I use variable my data read.csv, and I want to use this mobile price and I want to print, so I print my. Okay, you can see that I get the whole data. You can see that in this data set, there is a one column ID. Okay, so we have to understand that the ID is never used for analysis. So we cannot use this. So we have to drop this column. Or either we have to make a new data set, a new data frame, having not this column. Okay, so we cannot use this ID for any type of analysis. Okay, in this data set, you can see that depending on the features, it might be possible we can predict that there is a Wi-Fi connection in a data or not, because you can see there are two values in a data set, that is a 0 1 0 1 0 1. Okay, so we can use this. Look, let's first check that there is a missing value or not in this data set. So I have to use, you can see that there is a zero missing value. So we can directly spread the data into a training testing part. So I just copy this from here and use here. Now what I have to means do, I have to apply here my data. Okay, and okay, let's check that this is done or not. So I get this. Now this testing. Do you have the data set for loan defaulters? If you have the data set, then give to me. Then I tell you then how to do apply the need-based classification algorithm. If you have the data set, then please share. I will tell you, because in your data set you get a one column that either the customer is treated as a defaulter or not defaulter. So it might be possible there is a yes, no, there is a true, false. That column is used as a dependent, and rest all the columns are used as the independent, and apply the need-based classification. Okay. If you have a data set, then please share. I tell you. No, data set is not given by me. But if you have any data set for loan defaulters, then please share to me. Or if possible, because that loan defaulter data set is a, please find out if possible in a Kaggle. Okay, it might be possible there in Kaggle these type of data sets are available. Okay, now this is not necessity that you can scale the data set. If you want to scale that, then you can scale. Okay, so you know that we have to basically don't want to use this column number 1, that is a ID. Okay, so we have to anyhow remove this ID from our data set. Okay, so first I check the dimension of, means how many columns we have. So you can see that there are 21 columns. Okay. The last column we are treated as a dependent. So if we start from it to 20, it means the first column ID is removed from scale. Okay. If you are using ID, it doesn't give you any error, but it is means our decision that we don't have to use the ID for any analysis because that is a static values and assigned by some system. So we cannot use that for the analysis. For example, customer ID, employee ID, that are the columns are not used in any analysis. Okay. Now, if you have to use so what you have to change here, we want to use a column that name is Wi-Fi. I put here Wi-Fi and the rest of the columns are used as a independent column and I pass here scale data. Okay. Similarly, I also pass here scale. Now, if I run this, okay, we get the probability 1. That is not possible. I have to pass here dollar Wi-Fi. Okay, you can see that we get only accuracy of 53%. Okay, that is not good for this data set. So for that, you can change the split ratio. For example, if I change here 80-20 and run this, so you can see that again we get the accuracy of this 52.32%. Okay, so it means that it might be possible for net-based algorithm not giving the good result for this data set. So for that, you have to apply the another classification algorithm in the same data set to find out the another algorithm gives you a good result or not. Okay, so you have to just error and try with various algorithms of classification to check which algorithms gives you a best result in on what data set. Okay. There is a one data set that is an email classification data set. Okay, where there is a spam email, a social email. You know that in Gmail there are various sections like spam, social, then there is a primary section. So on the basis of the properties of the uh, mail, we can identify that that mail is treated as a spam or not. Okay, so these type of analysis is also going to we can perform with the help of the decision tree and node based classification algorithms. Okay, that data set is also available. Do you know what are the different sources of the data from where you can get this data? So I tell you one thing that there is a one website that is tagger.com. Okay, okay. So mostly the person who are learning about data mining on and all that, they use this source to getting the secondary data set. If you have your own data set, then it's good to you. But if you don't have and you just want to practice, then for that you can use this source for collecting the data set. Okay. So in that you have to first sign in to download any data set, and you can use any of your Google account to sign in. Okay. For example, I want to search this email classification data set. Email classification. Okay. You can see there are email classification data set available. Okay. So you have to just check which are the recent data sets. Mostly data sets are 2 years ago. This is one data set that is a 5 month ago. Let's check we get this data set or not. So in input, you can see this file is available, spam.csv. Okay. So on the basis of this, you can just download that file. Okay. If I open this file, you can also get code here. Okay. There are various researchers that are posting their work here. Okay. Okay. You can see this. This is a file. Okay. So this is a message of the email, and on the basis of that email, there is a one column category that gives you a this is a email, this is a not this is a spam, this is a not filling as a spam. These are the data. So which column you are treated as independent, that is the message. Anyone can write anything on the email. But what is dependent on the basis of the type of the message, on the basis of the text using in the message, you can classify that the category of the message is either spam or not. Okay, but for that you can see that this is a textual data. So in for that you require also a text mining. Okay, so you can first apply the text mining to identify what are the different keywords that are treated as a spam, and after that you have to classify using the classification. Mostly in email classification, the SVM classification, support vector machine classification algorithms are used for classifying. And Google is also, Gmail is also using the classification algorithm to classify that the email we are getting is going in which uh, inbox. Means either inbox, either spam, either social, where. And you also feel that sometimes Gmail also put our means important email in a spam. So no algorithms gives you 100% true results. Means there are chances that algorithms give either 0.1% false result, but there are chances. Okay, so we cannot say that algorithms always give you a true results. Okay. So this is all from my side. There is many more algorithms available for the classification, but due to less time, we cannot cover all algorithm. But these are the steps that is fixed for all the algorithm. The first step is you have to load the data set. You have to check if there is a necessity to pre-process the data set, finding the missing values and all. And after that, you have to divide data into a training and testing part. You can fix the ratio of training and testing. And mostly we are using a random sampling to divide the data set. And then you have to apply the classification algorithm on the training data set on the basis of the uh, independent and dependent column, and after that prediction is used, and on the basis of the predicted values by model and the actual prediction values available with us, we are making a confusion matrix to find out the evaluation parameters like precision, recall, and accuracy. Okay, so this is all from my side. If you have any question, then you can ask, please. Hello.
Yes, ma'am. There is
Okay.
one question or something like that.
These all thing is possible with the R and also with the help of the Python. But for that you required a data set. Okay. So we required a file. Uh, in this uh, this is not the data set. This is the one scenario I think that is given. That is bank loan debt dot SAD. Basically, this is done with SPSS. Okay. So in SPSS we can use a different file formats. Okay. So there are many types of many tools available. Like SPS is also using for data mining to providing the data. MATLAB is also using. So in all the tools, the data file format is different. Okay, so I don't know means the questions you are giving to me that which type of data set is there. So if I get the means raw data, then I can give you a good answer that how to apply this means either name base, either decision tree or the data set. This is a data set. You are telling a data set bank loan and dot str. So this str is I it means I don't know what is the file format. Can you please tell me that what is the file format you have? Because for apply the naive Bayes algorithm, we required a independent dependent column. So in str, I don't know means what type of file format you have. Can you please tell me the file format and or from where you get this data? Can I get the original copy of this data? Okay, so can you ask whosoever is giving you a data from where you download this data set at least? So if you are able to download this data set, we can open in a various tools and see that what the data set is. Okay, if possible, please give me a raw data set. I also tried that what this file format is, because it might be possible that you are using a different tool in your lab. That's why they are giving you this file format. It depends on the tools which file format are supporting to you. Okay, so I also tried to find out this file, and if I get this raw file now, I give you some idea, means how to apply. Okay. Okay, so you are using SPSS. Okay, so for SPSS it might be possible this file format is used. Okay, so do you have SPSS? Because SPSS is a licensed software, so means how you are using, I don't know. If you have SPSS, it might be possible if you get this file that is open. Okay. So, means if you find this raw file now, then in the tomorrow session, please show me that file in your SPSS, because in my system I don't have the SPSS. Okay. Then I give you some idea, means how to use this. Okay. Any more questions? Hello.
Yes, ma'am. I think no more questions, ma'am. Your email ID, they are asking your email ID.
You can search in a LinkedIn with my name, Dr. Shanti Verma, LG University. You can find me in a LinkedIn. Okay, and I already share you files, all the files I have. Okay, so, and if you have any doubt, you can just email me on. I'll give you my email address. Okay, so you can put just the email, and means I try to give you answers on time. Okay. And after completing means tomorrow's session, I make a one folder and share you all the means script file as well as PPT and data set also. So you can practice more. Okay, sir. That's all from my side.
Thank you. Thank you, ma'am.
Yeah. Thank you.
So we can wind up today's session and see you tomorrow.
Yes. Okay.
So good night, everyone. Thank you.